Hello everyone, welcome to another video lecture on the topic beta gamma function. So we will discuss the definition of beta gamma function in this topic and we will solve few problems on this. This is a short topic, so we will most probably try to finish in a one or two lecture. So let's begin. Well, let me ask you one question. What is the value of factorial 5? Well, anyone can answer. This is 120. Here is another one. What is the value of 3 over 2 factorial? Now you may hesitate to answer this. You will not be able to use the same technique you use it to find the value of 5 factorial. So here we define new function, that is a gamma function, which gives us a value of factorial for non-integer numbers. Now definitely if it works for non-integer, it will also work for the integer, but basically this is the generalization of a factor. You may take it in that way. It will give you the value of factorial even if the number is not a integer number. Okay, the gamma function is defined in the form of integral like this. So here we have a definition for a gamma function. Here is what this symbol, we use it for defining a function gamma, and n is any number now, not necessarily integer, it can be any real number, and this is integration from 0 to infinite this. So you need to know this function as a gamma function. Okay, this is a special type of function in the form of integral. Now if you take it further, you can see this is an integration from 0 to infinity. Integration from 0 to infinity with this function. There are two terms. If you use a simple higher secondary mathematics to explore this further, then you can do like this. If gamma of n plus 1, if you wish to find, then it will look something like this. Simply replace n by n plus 1 and you take x to the power n as first function and e to the power minus as second function. Well, you can explore it easily. So you'll get this simplification, and gamma n plus 1 will look something like this. Over here, this expression is exactly same as our gamma n. So we can replace gamma n plus 1 equals to n gamma n. This is very important, one of the important result in gamma function. So from this expression, for instance, what you can do is, if you wish to find gamma 3, it will look 2 gamma 2, gamma 5 will be 4 gamma 4, and so on. Okay. Now here we define one theorem, which is gamma n plus 1 is equals to n gamma n. This particular expression is important in order to solve problems later on. So this expression, first theorem, comes from this simple derivation is over here. And here further we have another result, that is what is the value of gamma 1. Simply you replace n equals to 1 on this function. So and integrate it, you will get the value equals to 1. Now let me derive one more expression which is again important for later on purpose. From this expression, gamma n plus 1 equals to n gamma n, that is this particular statement, and using gamma 1 equals to 1. Basically using 1 and 2, what can I write is gamma 2 equals to 1 plus 1, that is equals to 1 gamma 1. You just use this definition over here. And what is the value of gamma 1? Gamma 1 equals to 1. Similarly, you can do it for gamma 3, gamma 4, like that. Then what will you get for gamma 4? Suppose 3 gamma 3. Now gamma 3, you put the value from above, that is factorial 2, so it will get factorial 3. And if you generalize it, you will get gamma n plus 1 will be equal to factorial n minus 1. So here we have another important relation, or a property of a gamma function. Gamma n plus 1 is equals to n factorial. Okay, it is not exactly factorial, but it is factorial with 1 less. So the first is definition of a gamma function itself. Second, we proved gamma n plus 1 equals to n factorial. Third, we have this relation from here, and one more is gamma 1 is 1. So all these are important, and we are going to use this during while solving the problem. So here I will define another function, which is a beta function. Now beta function is again defined in the form of integral or by means of an integral, and beta function look like this. So here I have mentioned definition 1 as a beta function. This is integration. Now the limit has changed from 0 to 1, x to the power n minus 1 and 1 minus x to the power m minus 1 dx. Particularly, it has to be in this form. Okay, so there is another definition for a beta function which is in the form of radian, that is sine theta and cos theta. So we are going to use both of this definition in order to solve the problem later on. So properties of beta function. Well, one first property you can check easily is if you replace or if you interchange m and n, what you will find is you will find same thing. And another function, another property is beta half and half equals to pi. Now I'm not going to solve it for you. I want you to do this as an exercise. This is just a 2-minute problem. Replace n and m by half and half. What you will get it is sine 0 cos to the power 0, sine to the power 0 cos to the power 0, that is 1. Integrate it, you will get this quantity equals to half. So here we have two property which comes from this actually. There is another important term, that is relation between gamma function and beta function. How are they related? Well, I'm not going into the proof part honestly, so it will take a separate video to prove that, but my intention is not to prove the relation but to use the relation. So you need to know this relation as a whole. Proof is not difficult, but so beta n m will be equals to gamma n by gamma n plus 1. So this relation also is important for later on use. Well, keeping this relation, using this relation, we will do a small sort of calculation over here, and the calculation is what is the value of beta half and half. Beta half and half is this, using this relation, and from here I can use beta half and half value as pi, and so if you square it, gamma 1 value, you can go back and check the value of gamma 1, which is equal to 1. Square is there, so it is again another important relation throughout this lecture, that is gamma half equals to root over pi, so which actually come from this only. So you keep this as a note. So here's a problem from lecture 37, beta gamma function. Define the beta function gamma okay, and their properties and result. So we have already done this, so we will now use all this properties and definition to solve the problem from, of course, this lecture 37. So here I have the first problem using beta gamma function. If gamma n plus 1 equals to 6 gamma n minus 1, then find the value of this. So how to do this? I have a problem of solution over here. Before we explore this solution, let us try to collect those important relations from the previous one. So here we have gamma n plus 1 equals to n factorial. Let us keep it in mind. Okay, gamma n plus 1 equals to 6. Then how much is gamma n plus 1? This is n factorial. Gamma n minus 1 will be n minus 2 factorial. Now simplify the factorial, you will get equation in terms of n. Solve it, you will get the value of n. Here I have another problem on the screen. Evaluate this using gamma function. You may try to integrate this without using gamma function, but here we are going to use gamma function to evaluate this. Now in order to solve this, we have a solution over here. What I will do is, I'll first substitute the value. Now you must be thinking, how come I can directly substitute and try to get the value? Well, you can pause the video and see this simple mathematics, how it has been solved. Now my intention is to put this last integration in the form of gamma function. So how it will look like, you can go back and recall what is the definition of a gamma function. So here we have this e by 2 will come out. I'll take this e to the power 1 as outside and t to the power half. You can go through this. Otherwise you can do one thing. Why don't we bring the whatever definitions that we are going to use over here. Gamma n is e to the power minus x, x to the power n minus 1. My intention will always to put the whole my intention will be to put our integration in this form. So here I have e to the power minus t, and t to the power half I have changed it into 3 by 2 minus 1 because my definition is x to the power n minus 1. So I want to put it in the form of n minus 1. Then further, this definition perfectly hold for gamma 3 by 2. And again, you are going to use this second one, gamma n plus 1 equal to this. So 3 by 2, first you have to write it in terms of half plus 1, which is 3 by 2. Over here, if you put it in this form, then half is equals to n, 1 is over here. Then further, what is the value of gamma n plus 1? Gamma n plus 1 is equals to n gamma n. So n is half. You use the value of gamma half from previous property, substitute over here, you will get the result. Okay. So here I have another problem again from the tutorial sheet to evaluate this using again gamma function. So what can be done? Again substitution is required. We substitute x square equal to t over here, do this substitution and put it in this form. You can pause the video and understand this integration, which is just an higher secondary level integration. Over here again, in the previous problem it was t to the power half, we have here t to the power minus half. I want it to be in the form of 1 by 2 minus 1, that is n minus 1, which gives us gamma half. So this particular formula which just pop up on your screen has been used over here. Let me just color it. And this another formula, that is gamma half equal to root over pi, has been used over here. So you can go through this. So another problem, let us try to solve. Evaluate this using again, okay, nothing is mentioned. So this problem actually is not from your tutorial sheet, but I have decided to solve the problem. From the limit, you can guess over here, this particular problem is based on beta function. You can quickly go back and check the definition of beta function. So here we have problem. So what will you do is substitute again root over t equals to, sorry, x equal to t, and do this substitution. Okay, here it comes, the beta function is over here. So our intention is to put it in this form. So limit is already there, x to the power something is there, 1 minus root over x whole to the power something is there. So this substitution, let us see what will we get this with this substitution. So integration will take this form, and if you again multiply this t with t to the power 9, but my intention is to keep it in the form of x to the power n minus 1. So I'm writing 9 as 10 minus 1, and same I'll do it for this, which is actually a beta 10 6. Okay, 2 is there, no issue. Now again, to evaluate the value of beta 10 6, what do we do? Why don't we use the relation between beta and gamma function? So if I use this, I'll get this. Now in order to explore the value of gamma 10 and gamma 6, of course we know that gamma n plus 1 is n factorial, so gamma 10 is 9 factorial, and so on, and simplify it further. So here's another problem. This is actual problem from beta gamma function, I mean from the tutorial sheet. So I'm not going to solve it on this video. I want first you guys to solve it. I'll give you a hint. Do a substitution that x is equal to sign, because it will give you the value from 0 to 1. 0 to 1 will change to 0 to pi by 2. Now quickly go back and check a definition number 2 for beta function. Try to put this expression after substitution in that form and try to solve the problem. So all the best. Thank you.